So we got three things here. What do we have? We have graph, we have table, and we have words. What's the last thing? And the last thing is always seems to be the hardest thing for people. An equation for this, okay? And writing an equation for this. Writing an equation for this is basically taking this thing right here and translating it into letters and numbers, okay? We want to know, how do we calculate d from t, from time? How do you calculate the distance? What does this say? How do you calculate the distance? It says right here how to calculate the distance. It starts at 2. So I'm going to say I'm starting with 2, and then I'm adding on something to that. How much am I adding on? Am I adding on, if I take the number of seconds, how much am I adding on there? Let's do a few numbers first. So I'm going to make a space here. I'm not going to make a random line. I'm going to make a space. After 3 seconds, how much have I added on? How many times what have I added on after 3 seconds? Well, let's start it easier. After 1 second, how much have I added on? 1 second, how much did I add on here? 0.5. So I'm going to say I've added on 0.5 times 1. After 2 seconds, how much have I added on? 0.5 times 2, right? After 3 seconds, you're getting the hang of this now, 0.5 times 3. Let's jump ahead here, ... Let's jump ahead to 10. After 10 seconds, how much have I added on? If I say take 0.5 and times it by 10, that's going to give me how much I've added on, right? The way you write the equation of a line is you say, I take my initial value and I add on whatever the rate is times whatever that value is. Okay? If I take whatever the time is here, whatever this time is, and multiply it by my rate here. After 100 seconds, how many meters would I be adding on? If this were 100 times 0.5, what would that give me? How many meters would I have gained in 100 seconds? 50. You take the time, multiply it by 0.5. That gives you the distance, right? This is the equation of that line. You can represent it with an equation that way. You're going to find that to represent the equation of a line, you have two things. You have the initial value. I'm going to put y-intercept here even though we weren't using the word y. Y-intercept, vertical intercept, d-intercept. What did this number represent? Well, I'm going to put this in yellow. That's the initial value. In blue, we have what was that again? What's blue? What is that? That was the rate of increase or decrease. Rate of change. I'm going to put here it's the slope in brackets. To me, it seems totally obvious when you start with a real situation like that. Start here, add on however many of those you need to add on. You'll see that in your textbook, they don't necessarily write it like that with a specific situation. They write it with variables. So they're going to say, like, if we were using y and x here, it would say 2 plus 0.5 times x. We're not using y and x, we were using different letters. They use different letters for this. Often for the y-intercept, they use a variable, and often for the slope they use a variable. Do you realize that you could actually write this the other way around? Some people write it this way. They say 0.5x plus 2. Do you realize that this and this are the same thing? Does it matter what order you add things in? Does it matter if I go 2 plus 0.5x or I go 0.5x plus 2? Does that matter? Doesn't matter. Doesn't matter what order you do that in. Often you're going to see it this way, although I like it this way better. Why does this make more sense in the situation that we just had? Why does it make more sense for the 2 to come first? If you look back at the graph, it makes sense. Why does it make sense to put the 2 first in the equation? What did the 2 represent? The starting value, right? This is the initial value at time equals 0. That's how much we had at 0. To me, it makes more sense to say I started with this and then I added on this as time went by. This is called the constant term. You did polynomials in grade 9 and you learned constant term and variable term and stuff like that. This is the constant term. If I change the value of x, does it change what is inside this box? Inside this box is a 2. Does what's inside this box depend on what x is? This thing's always a 2. It's constant. It doesn't change it. What about this one? Does this change? Does the value that's inside the second box, does this value change based on what x is? This is called the variable term. Number 1, because it has a variable in it. Number 2, because it changes, right? It varies. You might have heard on, I don't know if you listen to ads when they talk about mortgage rates and stuff like that. They talk about fixed rate and variable rate mortgages. Variable, this thing can change. Fixed, this doesn't change. It's constant. That's the equation of a line. In general, you're going to find in the textbook they write it 2 ways. I think I'd like to put the constant term first, but for some reason in textbook they always put the variable term first. Sometimes they say ax plus b. They just say that's the slope, that's the y-intercept, or the vertical intercept. Okay, so if I'm highlighting it the way I did up there, that's the constant term. Constant term is the y-intercept. And the variable part here, that's the slope, that thing. The number in front of the x is the slope. For some reason, some people don't like a. I don't know why. And they write, in your textbook, you probably see m for the slope. I think this is probably on your formula sheet, your Ma10 formula sheet that you get on the provincial exam. They use an m for slope. It doesn't really matter. I don't want you guys to get so used to a single thing that you can't recognize it. Basically, if you have some number that's constant without any variables, plus a variable times a constant, or just a variable, it's a straight line. To recognize, this is the hardest to recognize. We need to be able to recognize from each of these representations whether something's a linear relation. To recognize it from a graph is easy. How do you tell if a graph represents a linear relation? If it's a line, linear relation, straight line. If it doesn't curve. How do you represent from a table? Theoretically, you learned this in grade 8. How do you recognize from a table whether something's a linear relation? If you look at the changes here, what do you notice about those changes? This is like you're adding 2 each time. Every time you add 2, that corresponds to this, going 2 over, plus 2, plus 2. Every time you jump from one point to the next, plus 2. And if I make a jump the other side here, how much does this change? Plus 1, plus 1, plus 1. It's going up plus 1 every time, plus 1. If this weren't a linear relation, like if suddenly this curved up now, and this was a plus 3, you'd see that in the table. For it to be a linear relation, from a table, how can you tell? How can you tell from these things that this is a linear relationship? From the table. Goes up by the same thing. And you need to understand it more than the grade 8s did, because even if you skip a number here, the next one here would be 8, and how much would it be over here? It'd be 6. But what if this was 10? What would this be over here if that was 10? 8 would be 6. 10 should be 7, right? Now you notice how much did this go up? This went up 4. How much did it go up on the other side? 2. So it isn't that all the numbers have to be the same. It's that the ratio of this to this has to be the same. That's a 1 to 2 ratio, 1 to 2 ratio, 1 to 2 ratio, 2 to 4 ratio. 2 to 4, isn't 2 to 4 the same as 1 to 2? if you have one car for 2 people, and then you have 2 cars for 4 people, that's the same ratio, right? It has to be the same ratio. It doesn't have to be all the same jump. That's how you recognize from a table. From a description, if you have a starting value and something at a constant rate, steadily, constantly, at the same rate the whole time. That's how you recognize from a description. From the equation is the hardest thing. Let me write a few for you and let's decide here. So we'll do this. Is it linear? Need some dramatic music for that. I don't have any. Is it linear? So we already saw if somebody said y equals 2 plus 0.5x. The answer was yes. If we said 2 plus 0.5x squared, 2 plus 0.5x squared, the answer is actually going to be no here. As soon as you have something, you have a variable there. If you want to convince yourself, we could graph that thing. We could even make it simpler and just get rid of the 0.5x squared. If you do 2 plus x squared, you're going to see that it's not linear. If you don't believe me, let's draw a graph of this really quickly. What would this be for if we wanted to create a graph of this? How can we create a graph of that thing? I realize this is a long lecture today, and usually the lectures aren't this long. 32 going on 32 minutes here. I understand. I know that's long, but this is a lot of the ideas in this chapter that I want you to know. If we wanted to create a graph for this, how can we create a graph? You should know going into grade 10 here, but we might need to be reminded. How can we create a graph? You probably have to start with doing one of the other representations. What would you have to make? What would you have to do first? What? Make a table. Make a table. If we were to make a table, let's start at 0 because that's a good thing to start. What value would you have here if you started at 0? You can just put 0 in here and say 0 squared plus 2. I don't care if you show your work for that or whatever. What would that value be? 0 squared plus 2? 0 squared is 0. Plus 2 is 2. You're going to find out at some point that if you have any crazy stuff plus a number here, that's probably going to be something to do with this starting value. What about if you put 1 in here? What about if you put 1 in here? You can think through this. I want you to be able to do this in your head. Okay? I want you to be able to say 1 squared plus 2. How much is that? 1 squared plus 2. 1 squared is 1. And 1 plus 2 is 3. Thank you for answering what 1 plus 2 was. 2 squared plus 2. What was that? What would that be? 2 squared plus 2. 2 squared is 4. Plus 2 is 6, right? 2 squared plus 2. What would 3 squared plus 2 be? So we started with 3. What would we get here? 3 squared plus 2. 3 squared is 9 plus 2 is 11. That's enough to decide whether it's linear or not. We have 0, 2. If I'm putting these dots on here, 0, 2, 1, 3, 2, 6, 2, 6. You can tell already. Is it linear? It is not linear. 3, 11 is going to be off my grid. It's going to be way up there. 3, and that's 6, 8, 10, 11. It's actually a curve, okay? This one you're going to learn about in grade 11. It's actually a curve, and there's no reason it couldn't be on this side. I think if you put in negative numbers, you'll find it looks like this. It's definitely, okay? It's not, whether you're taking pre-calculus or foundations, you are going to work with that type of graph, okay? It is called a quadratic function. It is when something is squared, it's called a quadratic function. When you have the variable squared, it's going to make that curve. Definitely not linear. Is it linear? No. For this year, all we have to know is, well, you can just develop a shortcut for yourself. If you see that there's a squared or a higher power there on the variable, it's not linear. If there's a square root or something like that, not linear. Y equals 2x. What if it just said y equals 2x? Let's shrink this table down here. We don't need it anymore. This was a yes. That was a no. What about if it just said y equals 2x? That's a simple one to make a table really quickly. Give me some numbers. What if x was 0? What would y be? No, it would not. What does this say in words? Take x and do what to it? Times by 2. Take 0 times by 2, what do you get?
0.
Take 1 and times by 2, you get 2. Take 2 and times by 2, 4. 3 is 6. 4 is 8. We have lots here, right? Is that looking like a linear relationship? Yep, because every time you jump 1 here, you jump 2 over here. That's a linear relationship. You can tell because it's this part of it. It's the variable term. It's variable term and or linear term is going to give you a straight line, a linear function. Any linear function, if you're looking at an equation, if you have y equals, if you want to put it in grade 10 speak, you say number without variable plus number with, well, they'd probably just say x, but we could say variable. Number with variable with no squareds or anything like that. Does that make sense? Squared does, I don't know how you, grade 10 speak, squared does, that's not really a word, of course, but with nothing squared. Nothing squared or any other weird stuff. Well, I mean, probably your notes would be better if we put it in just how you would say it instead of how the textbook would say it. But basically, if I say y equals, somebody give me a number. 2. Well, we just had that. Come on. 6. Way to think big. And plus 12. Way to think even bigger. 12x. That's a linear function. Give me some other number here. It can be, don't give me whole numbers this time. Somebody give me a number. Give me a number. 25. Not a whole number. Oh, 4.5. Good. Okay, 4.5 plus, give me a number. That's not a whole number.
3.2.
That's a linear function. Y equals, give me some kind of, what about a fraction? Can I put a fraction here? Fractions are numbers too. Don't be discriminatory. 3/5 plus 7 over 9 x. Don't be caught up in that the constant has to come first. I know I said I like it better that way, but again, what if it's the other way? What about if the numbers were negative? What about if we had this first? Let's get really crazy and put the variable term first. Negative 7 over 200x plus, actually minus, let's get crazy, 5 over 2. That's really crazy. If you took this out, still a linear function, it just starts at 0. If you took this out, still a linear function. It's actually a really easy linear function. I've gotten way ahead of what you learn in this section, but you actually have a lot of the sections now. Okay? This is a lot of what's in a lot of the sections. The only thing I didn't talk to you about that was on my list here was, should the points be joined or not? Continuous, discrete versus continuous. You are going to find that out from the book pretty easily. Okay? I will talk to you about that after lunch. For now, I want you to get started on working with this. This section first asks you to say, what is a relation? What is linear versus nonlinear? I'm really hoping you can answer that one without just copying what the textbook says. It'd be quicker. I'm hoping now at this point you can say what dependent versus independent variables are. If you want to look in the textbook for discrete versus continuous and put something down here, that would be good, because even if we talk about it after, that would be helpful. The examples that are in here have you look at a situation, represent things two different ways. A table and a graph, and answer some questions about it. can you get going on that right now? And then after lunch, you're going to keep working away at it. We're going to get a good chunk of stuff done today.